RoboSense. We are a Chinese LiDAR sensor system provider. I am Zara, and I will be your host for today. So now we are at the exhibition hall of RoboSense. Here we are displaying all the product lines that we are marketing at the moment, including the mechanical rotary LiDARs. This one is a 128 beam LiDAR. We call it RS-Ruby. And this one is a blind spot detection LiDAR called the RS-BPO. And here we have our early mechanical LiDAR products, the RS-LiDAR-16 and RS-LiDAR-32. So most importantly, here we have the RS-LiDAR-M1. Right here, I have one RS-LiDAR-M1 and a conventional 128 rotating LiDAR here. So comparing the two together, we can obviously say the difference. So first of all, the M1 has a very small footprint. This one is the SOP version that we will start the mass production at later this month. So the size of this one, it has 108 millimeter depth and 110 millimeters width and a very small height of only 45 millimeters. So considering the size, it is the most compact option of all the similar technology products on the market. Secondly, this product has a very clean and sleek cuboid shape. Comparing with the bulky size, the rotating LiDAR, the round-shaped LiDAR, this shape is more in line with the aesthetics of the automotive OEMs. Besides, this one is very easy to be embedded into the vehicle body. So this is one of the reasons why this product is favored by our automotive customers. Thirdly, this one has adopted pure solid-state and modular design. The number of the parts and components has been greatly reduced compared with the traditional rotating LiDAR. And it is very suitable and easy to be put on the automated production line. And it has helped the automotive industry solve the major two pain points, including the mass production and the low cost. So after we have checked the M1 product in real, now let's go downstairs and check how it looks like when it is embedded on the vehicles. As you can see, there are two cars parked here. They are two of the testing vehicles used by our technical team to verify the performance of the RS LiDAR on the car. On the white car, we have a reference system, and on the black car, the sensor mounting position are simulating the solutions for automotive OEMs. So now let's take a closer look at each of these cars. Reference systems are always taken by the autonomous driving companies to verify the other sensors of their autonomous driving system. And in our reference system, we have provided 128 rotating LiDAR as Ruby to provide the ground truth data for the mapped LiDAR. And on this system, we have integrated 6 M1 LiDAR, 3 at the front, 2 at both sides, and 1 at the back. We also have integrated 5 cameras and 1 RTK. For mass production vehicles, the LiDAR sensors are usually required to be embedded into the vehicle body. For example, on this car, we have embedded 3 RS LiDAR-M1, 1 mounted at the grille position to face in front, and 2 at the headlamp to cover the blind spot area. So each of the M1 LiDAR provides a 120 degrees horizontal FOV and 25 degrees vertical FOV. So for L3 and lower ADAS systems, the LiDAR sensors are usually mounted at the front or at the vehicle rooftop to provide redundancy to other sensors in the system, for example, the cameras or the radars, ultrasonic radars. But for level 4 and higher level autonomous driving, so multiple LiDAR sensors are required to be mounted at the different angles of the vehicle to provide a 360 degrees coverage of the driving environment. So now let's follow one of the car to take a ride and check the performance of the M1 when the car is driving on the road.
So this test vehicle have put an IPC at the back, and the sensors will connect the environment information in real time and feed it to the computer. The computer then will process this information and display them on the screen in front of each seat. So the passengers at the back can check the point cloud performance of the M1 in real time. So let's move the car and get on the road. So the innovation of the M1 is mainly embodied in 2 points. One is the gaze function similar to camera zoom, and the other is the point cloud environment perception algorithms at the software level. The gaze function supports the activation of the ROI when driving on highway. The angular resolution in the ROI can be doubled or even tripled, which can clearly show the details of small obstacles and moving vehicles in the distance. When driving on city roads, the ROI can be turned off to increase the refresh rates to quickly update the system with the near-field information to avoid annoying cuttings and unwanted fender benders. At the software algorithm level, the intelligent M1 has built-in RoboSense exclusive point cloud environment perception algorithms, including like positioning, road sign detection, obstacle recognition, tracking, classification, etc., which can directly output target level perception results. So now we are at a very busy intersection of the city road, and there are traffic flows in 4 different directions. And the algorithm is now outputting the target level perception results. They are doing the classification of different traffic participants and using a bounding box to mark them out, like the trucks, buses marked out with the big blue bounding box, and the cars and taxis marked out with smaller red bounding boxes. And also there are the bicyclists and the pedestrians are all marked out with different bounding boxes. So the algorithm is not only classifying them but also detecting their location and their moving speed, moving direction, and all this information of these traffic participants are collected and reported to the autonomous driving system.
So LiDAR sensors is becoming an inseparable part of the environment perception system of the autonomous driving. So as LiDAR M1, designed in full compliance to the automotive quality and functional safety requirements, boasting with its small size, low cost, and intelligence in the hardware and the software level, it deserves the name as a disruptive and innovative product. Thank you for your time.